All right, well, let's get into vertical and asymptotes here. Vertical and horizontal asymptotes, that is. Anytime you have a vertical asymptote, that's where your, like if you have a rational function and your graph is looking something like this, and like so, while you have a vertical asymptote that is going to be an undefined value going through like this, where your purple graph does not touch it. You also have horizontal asymptotes, which would go through something like this. Now you only have, at most, one horizontal asymptote. You can have multiple vertical asymptotes, but you're only going to have one horizontal asymptote. So let's look how you find your vertical asymptotes. Well, your vertical and your horizontal asymptotes. Your vertical asymptotes are just your zeros of d of x, which is the zeros of your denominator. Notice how your denominator is d of x, and then your numerator is n of x. So to find your vertical asymptotes, you have to just find your zeros of your denominator. Now, in order to find your horizontal asymptotes, you have to read. These are determined by comparing the degrees of n of x and d of x. So you have three different possibilities here. If n is less than m, then you have the asymptote of y equals 0. So that's your horizontal asymptote. If n is equal to m, so these are the degrees of your n of x and d of x. So n is your degree of your numerator, m is the degree of your denominator. So let me rehash this back here up on A. So if the degree on top is less than the degree on bottom, that's when you have y is equal to 0 as your asymptote. If they're equal, then what you do is you take your coefficients right here, set them up, and just set it equal here. So for instance, if you had something like y is equal to 2x squared minus 3 over x squared minus 7, notice that their degrees are the same. So then what you have to do is you have to look at their coefficients up front. So you have a 2 and a 1, so that means your asymptote would be 2 over 1, or just 2. If your third case is when you have n is greater than m, that is when you have no horizontal asymptote. And that means you're going to have a slant asymptote instead, which we'll get into eventually. So if we look at example 2, we need to find all your asymptotes. We're going to find your vertical asymptote first, that's the easiest, and then we're going to find a horizontal asymptote. So for your vertical asymptote, you just take your denominator, set it equal to 0, and you end up, you can factor this, or you can just add 1 to both sides, and when you take the square root, you get x is equal to plus or minus 1. So in this case, you have 2 vertical asymptotes. Now your horizontal asymptotes are from when you have to look at your degrees. So the degree on top is the degree, same as the degree on the bottom. So since n is equal to m, that means you're going to take your coefficients on top divided by the coefficient on the bottom, your leading coefficient, which just gives you a horizontal asymptote at y is equal to 5. So that's 2a. 2b, if you look at your vertical asymptotes, in this case, if you set your 3x squared plus 1 equal to 0, you're going to subtract 1, divide by 3, and then if you take the square root of both sides, you're going to find out you're going to get an imaginary solution. So since you have imaginary solutions, that means you're not going to have a vertical asymptote. So no VA for short. Your horizontal asymptote, you might actually have one of these. So you have to look at your degrees. You have a degree of 1 here, you have a degree of 2 here. So since the degree on top is less than the degree on bottom, that means your y asymptote is going to be y equals 0. So that is the easiest way to find your asymptotes.